Hello everyone, myself Prasanakumar, Assistant Professor, Department of Civil from VSB Engineering College, Karur. Today discuss about the topic of Unit 1 of Hydrology and Water Resource Engineering. In the Unit 1, we can give detailed information about the precipitation and the abstraction. At the end of the Unit 1, students are able to gain knowledge about what is meant by global water cycle and the precipitation, evaporation and infiltration and analyze the hydrological data to solve the water budget problems. Next, we see about the hydrology. Hydrology is a scientific study of the movement, distribution, and the quality of water on above and below the earth surface. Next, we see about why hydrology is important because it gives clear information about the planning of water supply project and the designing of dam and reservoirs, federal control and management as well as groundwater improvement. What are the main application of this hydrology in civil engineering field was during the time of bridge design. This give clear information about the groundwater resources as well as reservoir planning and flood forecasting. Next we see about the hydrological cycle. It is a defined as the continuous circulation of water between the atmospheric, ocean and the land through the various processes. There are five different processes would be followed hydrological cycle. They are evaporation, condensation, precipitation, infiltration, runoff. First, see about the evaporation. Evaporation it is a process during the water from the ocean rate and the river changes directly into the water vapor with the help of solar energy. After the evaporation process, condensation should be take place. Water vapor cools and changes into tiny droplet and forming the clouds. After the condensation process, precipitation should be carried out. Water from the clouds directly forms a rain or snow. After the precipitation process, infiltration should be take place. It is defined as a part of the rainfall that enter into the soil surface with the help of pores present in the each and every type of soil. After the infiltration process, runoff should be carried out. Runoff is defined as the water flowing over the land surface towards the rivers. Finally, we see about what is the significance of hydrological cycle. It will maintain the water balance and automatically increase the groundwater resources and also support the life on its surface. In next we see about meteorological measurement. Meteorological measurement it is defined as the record in the atmospheric condition that can be followed during the time of rainfall and the weather. There are four different parameters to be followed. Temperature, atmospheric pressure, humidity, wind speed as well as wind direction. Temperature is defined as the measured degree of hotness or coldness of air. By using the thermometer, temperature should be calculated. Atmospheric pressure is defined as the force exerted by air on the earth's surface. By using the barometer, atmospheric pressure should be calculated. Humidity defined as the amount of water vapor present in the atmosphere. By using the hydrometer, humidity should be calculated. Wind speed is defined as the rate of momentum of air in all directions. By using the anemometer, wind speed should be calculated for each and every direction. In next we see about the precipitation. Precipitation is any form of water that falls from the atmosphere to the earth's surface. There are five different forms of precipitation should be take place. They are evaporation of water, cooling of water vapor, condensation into cloud, drought of water droplet, falling as precipitation. In evaporation of water, evaporation is nothing about the entire water should be directly converted into water vapor with the help of solar energy. After the evaporation of water, directly cooling of water vapor should be take place. After the cooling process, condensation should be take place. Condensation is defined as the entire water vapor converted into tiny water droplet and enter into the cloud formation. After the condensation process, dot of water droplet should be take place. As finally, after the dot of water droplet, precipitation should be occurred. What are the conditions required for precipitation was moisture availability, cooling of air and cloud formation. Next we see about the types of precipitation. Convective precipitation. It is one of the types of precipitation. It defined as the occur when the sun intensely heat the earth's surface, causing warm and moisture to rise rapidly. As this air ascends, it cools and condenses and forms an heavy rain. The main advantages of this precipitation was to provide intense rainfall during the short interval of times. Next we see about the form of precipitation. There are 5 different forms of precipitation: rain, drizzle, snow, hail and sleet. Depend upon the droplet diameter, there are 5 different types of arises. When a liquid water droplet greater than 0.5 mm diameter, it should be a rain. When very small water droplet lesser than 0.5 mm diameter should be named as drizzle. Snow is ice crystal formed at a very low temperature. When a large ice balls formed in a thunderstorm should be named as hail. Next we see about the orographic precipitation. Is defined as the occur when the moist air forced to rise over the mountain or elevated landform. As the air rises, it cools and condenses to form a cloud, resulting in heavy rainfall on the mountain slope facing the wind while leaving the opposite side dry. There are 4 different processes to be followed. First of all, moist air approaches the mountain. After that, moist air should be rises and cooling process should be take place. After the cooling process, condensation will occur. After the condensation occur, rainfall on the only on beaver side. The best example of this precipitation is it will be occur only western part of India. Next we see about the rain gauge. Rain gauge is the instrument used to measure the amount of rainfall received at a particular rotation as a specified period of time. The main purpose of rain gauge is used to measure the rainfall analysis as well as field studies, and mainly used for reservoir design as well as particular rotation whether the reservoir is suitable or not. There are 2 different types of rain gauges: non-recording type rain gauges, recording type rain gauges. In non-recording type, record only total rainfall only. When compared to the non-recording type, recording rain gauge record rainfall intensity as well as duration continuously. Next we see about the Simon's rain gauge. It is one of the non-recording type of rain gauge. It is widely used to collect precipitation and measure the total amount of rainfall that occurred over the 24 hours of period. The working principle of this rain gauge was rainwater enter through the funnel and it is collected in the bottle. After that, the collected water is measured by using the measuring cylinder. The main advantages of this rain gauge was simple in design, most accurate value should be calculated, low cost. There is one of the limitations should be present of this rain gauge was there is no continuous record of rainfall. Next we see about the facial analysis of rainfall. It is defined as the estimate how precipitation amount vary across the different geographical region. It transforms the scattered point measurement into the continuous mapped climatic data, which is essential for agricultural, food management as well as water resource planning. The primary goal of this measurement was calculate the average rainfall over a watershed or region using the point measurement from various types of rain gauges. There are 3 different types of methods should be followed. They are arithmetic mean method, Thiessen Polygon method, and ISO-Elder method. Next we see about the arithmetic mean method. Arithmetic mean method is a simple method and calculate the average by adding up of the rainfall total from of all gauge sessions and dividing by the number of sessions. The formula should be followed by arithmetic mean method where P is equal to P1 plus P2 up to Pn divided by n, where P is the average rainfall for each and every gauge session and n is defined as the number of sessions should be presented for each or particular location. Next we see about iso-ideal method. It is a define as or analyze the uses of contour of equal precipitation on the catchment map. The average rainfall between adjacent isolate is then weighted by the surface area enclosed between them. Mainly iso-elder method by with the help of contour map easily identified. There are 6 different types of steps should be followed. They are collect the rainfall data, which means obtain rainfall data from all different rain gauge stations. After the collection of rainfall data, plot rain gauge station with the help of contour map. After that, the isolate should be take place. For an example, for each 50 millimeter to 100 millimeter, 1 or 2 isolate must be present. In next process, divide the entire catchment area into the smaller rainfall zones. After that, calculate the area between the separated zones. In final, we can calculate the average rainfall by using summation of A multiple by P divided by summation of A, where P is the average rainfall for each and every station, where A is the area between the each location. In next we see about the interception. It is a process where the precipitation right rain or snow is capped by the plant leaf and the surface debris before it reaches the down surface. It plays an critical role in the nature water cycle, as well as it gives clear information about how much water evaporate or infiltrate the soil or became runoff. How interception will happen. First of all, rainfall from the cloud surface. After the rainfall, water first touches the leaves, branches, and roof, etc. At that time, some of the water, say here, remaining water should be reaches the down surface. What are the factors affecting interception are vegetation type, rainfall intensity, wind velocity, as well as temperatures. Next we see about the evaporation. Evaporation, it is a process where liquid water absorbs heat and transform into invisible gas such as water vapor. It acts as a primary force in the natural water cycle and moving the moisture from the earth surface and back into the atmosphere to form a cloud and a precipitation. Next we see about the what are the factors affecting evaporation was temperature, wind speed, humidity, atmospheric pressure, and solar radiation. Next, we see about the evaporation suppression method. It is a method that is used to reduce the water losses due to the evaporation from reservoir, lakes, canal, and the pond. After that, what is meant by evaporation? Evaporation, it is a process when direct water is converted into water vapor by means of direct sunlight. It is otherwise defined as the when sunlight and heat causes the water is directly converted into the water vapor. Some techniques are used to save that water. Why evaporation suppression is needed was saves water in reservoir, increase the availability of water storage, useful in dry and hot area, and also reduce the water shortage in the dry season. Next we see about what are the methods to be followed of evaporation suppression. 14 cover. It is the first method. 14 material cover the water surface. Mainly polyethylene sheet can be used. Up to 80 to 95 percentage of evaporation rate should be reduced. The main advantage of this method was both sunlight as well as reduce evaporation gently. Next we see about the wind better. Planting teams are building fences around the perimeter of the water body, reducing the wind velocity, keeping a productive bandit of humid air over the water. The main advantages of this method was less air movement as well as produce lower evaporation rate. Next we see about what are the factors affecting evaporation was temperature, wind speed, humidity, surface area and sunlight exposure. The main advantages of this evaporation suppression method for conserve water and that water can be useful in dry season, improve irrigation efficiency as well as improve groundwater facilities and increase reservoir life. Next we see about the infiltration. Infiltration, it is a process where the rain or surface water sinks into the ground and become groundwater. It acts as a nature ultimate water manager and playing a critical role in water cycle by naturally purifying water, preventing flood and refilling the underground aquifer. It is a process by which any kind of water directly enter into the soil from the ground surface. How infiltration happens? First of all, rainwater is fall directly on the land surface. After that, water reaches the soil surface. Then water directly enter into the pores that are present in the soil and moves towards the downward. Then automatically groundwater get discharged. When the amount of infiltration is high, more amount of water can be directly enter into the soil surface. Next we see about what are the factors affecting infiltration was soil type, rainfall intensity, vegetation cover, soil moisture and land slope. In soil type, which soil contain more number of pores, automatically infiltration rate should be higher. For example, sandy soil, water enter quickly due to the presence of pores. Next we see about the rainfall intensity. Heavy rainfall may causes a runoff when compared to the heavy rainfall. Moderate rainfall automatically increases the infiltration rate. Next we see about vegetation cover. Vegetation cover defined as when the roots of the plant takes a place in the soil. By utilizing this space, rainwater or any other water directly enter to the face and moves towards the downwards. Next we see about the land slope. Land slope definition, there are two different types of land slope. They are flat land and steep slope. In flat land, more infiltration rate should be occur when compared to the flat land. In steep slope, more runoff should be occur. Next we see about a double-linked infiltrometer. Double-linked infiltrometer is a standard, easy to use field tool designed to measure how quickly water enter into the soil. The main purpose of this method was to measure the infiltration rate in the field itself. It consists of three different types of arrangement. They are inner ring, outer ring, and water supply arrangement. First of all, water is maintained at a constant depth in the both ring. After that, infiltration rate should be calculated for each and every water drop that are present in the inner side of ring only. Next, we see about the infiltration index. Infiltration index is a simplified numerator value used in hydrology to estimate the average rate at which rainwater enter into the soil. It helps the water resource engineer to calculate how much rainfall will become the surface runoff. There are two different types of infiltration index, pi index and W index. Pi index is defined as the average rainfall intensity above which the volume of rainfall equal to the volume of surface runoff. The pi index should be calculated with the help of this formula. Total rainfall subtracted by the runoff divided by the total duration. Next we see about the W index. W index is a refined version of pi index. It removed the initial water loss of entire process. This made more accurate. Formula of W index is W is equal to P minus of Q minus of IA divided by T, where P is the rainfall, Q is surface runoff, IA is initial loss, and T is the duration. At the end of the unit 2, students have gained knowledge about what is meant by hydrological cycle, what are the steps involved in entire hydrological cycle.